Hello everyone, this is Chandan Jha, and in this video I am going to discuss complementary angles of trigonometry. This is the part 2 for basic concepts of trigonometry for classes 9 and 10. In the part 1 we have discussed the 6 ratios of trigonometry. If you have not watched that video, then the link has been given in the description. Please watch that. Now without any delay, let us discuss complementary angles. For that we are considering one right angle triangle, right angle at B and angle C as theta. Then what is complementary angles? Now we define these complementary angles as if the sum of two angles is 90 degree. If the sum of two angles is 90 degree, then the angles are known as complementary angles, or we say they are complementary to each other. For example, in this triangle, angle A plus angle B plus angle C is equals to 180 degree. Now if we substitute these values, that means for angle B 90 degree, for angle C here theta, then we get angle A plus 90 degree plus theta is equals to 180 degree, and thus angle A is equals to 90 minus theta. That is this one. So in this triangle, if you add 90 minus theta and theta, then minus plus it will be cancelled and we simply get 90 degree. So thus angle A plus angle C is equals to 90 degree. We can get this relation from this equation also, that 90 degree it will be subtracted from 180 degree, and thus we get angle A plus angle C is equals to 90 degree. So observe here, if the sum of two angles is 90 degree, here it is fulfilling this condition. Thus in context of this triangle we say angle A and angle C are complementary angles. So now how it is relevant to trigonometry, let us understand. We are considering the same triangle. Now if sine theta is perpendicular by hypotenuse, then sine of angle C, that has been already discussed in the previous video, can be written as AB by AC, that is opposite by hypotenuse, and sine of angle A for this triangle can be written as BC by AC. Now if we substitute this value theta in place of C, then we get sine theta is equals to AB by AC, and for angle A we are writing 90 minus theta, that is BC by AC. Next is cos theta. Cos theta is known to us, that is base by hypotenuse, and this angle C, base is BC and hypotenuse is AC. Similarly for angle A, so cos of angle A, this base is AB and hypotenuse is AC. Thus in place of C we can write theta and we get cos theta is equals to BC by AC, and in place of angle A we get cos of 90 minus theta, that is equals to AB by AC. Now the thing to observe, sin theta is equals to AB by AC and cos of 90 minus theta is also AB by AC. Both the ratios are same. So from these two equations we get cos of 90 minus theta is equals to sin theta. Similarly, sine of 90 minus theta is BC by AC and cos theta is also BC by AC. So both the ratios are same. Thus we get sine of 90 minus theta is equals to cos theta. These two relations are very important. Similarly, let us see another ratio. So tan theta is sin theta by cos theta, opposite by base. So in context of this triangle, tan theta, that is opposite by base, so AB by BC, and tan of 90 minus theta is again opposite by base. So for 90 minus theta, opposite is BC and base is AB. Here we are writing this. Next, cot theta. Cot theta is reciprocal of tan theta, and that is cos theta by sin theta, and ultimately it is base by opposite. So in context of this triangle, cot theta, here it is base by opposite, that is BC by AB, and cot of 90 minus theta, base by opposite, so AB is base for 90 minus theta and opposite is BC. So here we can see tan of 90 minus theta is BC by AB and cot of theta is BC by AB. So both the ratios are same. Thus we get a relation tan 90 minus theta is equals to cot theta. Similarly, tan theta is AB by BC and cot 90 minus theta is also AB by BC. Thus both the ratios are same. So we get one more relation. Cot of 90 minus theta is equals to tan theta. Similarly, we shall define sec theta, that is reciprocal of cos theta, and formula is hypotenuse by base. So in context of this triangle, we get sec theta is equals to hypotenuse, that is AC, by base BC, and sec of 90 minus theta, that is hypotenuse again AC, by base in this context it is AB. Now cosec theta, that is reciprocal of sin theta, so hypotenuse by opposite. So here cosec 90 minus theta, hypotenuse by opposite. For 90 minus theta, opposite is BC, so AC by BC, and cosec theta is AC by AB, because for this theta, opposite is AB. Now here sec 90 minus theta is AC by AB, and cosec theta is also AC by AB. So cosec 90 minus theta and cosec theta, they are same. Thus we can write sec 90 minus theta is equals to cosec theta. Similarly, sec theta is equals to AC by BC, and cosec 90 minus theta is AC by BC. So both the ratios are same here, and we can write then cosec 90 minus theta as sec theta. Thus we are getting these 6 relations in complementary angles of trigonometry. The 6 relations are sin 90 minus theta is equals to cos theta, and then cos of 90 minus theta equals to sin theta. Similarly, these two are interrelated, and sec and cosec are interrelated. It is very simple to memorize. We can see it's there in the name, sine and cosine. Cosine means complementary of sine. Thus, they have a relationship in between them of complementary angles. Similarly, tan and cot, that is complementary of tan, and thus there is a relationship in between them of complementary angles. Similarly, sec and complementary of sec. So thus we get sec 90 minus theta is cosec theta, and vice versa. Next, let us understand by examples. So here one question is there. Find the value of cos 35 degree by tan 15 degree, multiply sec 20 degree by sin 55 degree, and cot 75 degree by cosec 70 degree. Now one interesting thing to observe here, you see cos 35 degree and cos is complementary to sin. So you see 35 degree and 55 degree. If you add them, you will get 90 degree. So thus it is, the angles are complementary to each other. Similarly, tan is complementary to cot, and you see here it is tan 15 degree and cot 75 degree. Here also if you add them, you will get 90 degree. Similarly, sec and cosec, they are complementary to each other, and the angles which are given in the question, they are complementary. So the questions based on this part of trigonometry will have the complementary angles always. Means the angles which will be given in the question, you have to be little careful, and you will find out that the angles are complementary to each other. Now to solve such type of question, let us understand what are the steps can be taken. So first of all, we can write this cos 35 as 90 minus 55, because the complementary is already present here, and tan 15 can be written as 90 minus 75. So you see 90 minus 55 is 35, 90 minus 75 is 15. So we are not changing anything, we are simply rewriting this 35 degree and 15 degree. Similarly, sec 20 degree can be written as 90 degree minus 70 degree. So thus sec 90 minus 70. Now we are not going to change these 3 ratios, because the complementary of these 3 ratios have already been changed here. So it is not necessary to change here. Otherwise again we shall go back to the question. Now the next statement, what we shall get? Cos 90 minus theta is sin theta, tan 90 minus theta is cot theta, and sec 90 minus theta is cosec theta. Just now we have discussed. So instead of writing 90 minus 55, cos of 90 minus 55, we can write sin 55. Instead of writing tan 90 minus 75, we can write cot 75. And instead of writing sec 90 minus 70, we can write cosec 70. Thus, our equation will become sin 55 by cot 75, cosec 70 by sin 55, cot 75 and cosec 70. So you could see that all the ratios will be cancelled and finally we get the answer 1. Let us do one more example. Find the value of tan 23 degree, cosec 17 degree minus sec 73 degree and tan 67 degree. You could see here cosec and sec complementary given, but here also tan and here also tan. How to solve this then? So it's very simple. This by tan sec 73 degree by tan 67 degree can be rewritten as cot 67 degree because 1 by tan is cot. Now we can find that all the complementary angles are there. 23 degree, 67 degree, their sum 90 degree. 17 degree, 73 degree, their sum is again 90 degree. So we shall change this 23 degree as 90 minus 67 and cosec 17 degree as 90 minus 73. So, and here cot 67 already we have changed, so we are not writing in terms of 90. So tan 90 minus theta, that is cot theta, and cosec 90 minus theta is sec theta. So ultimately we shall get here cot 67 degree, sec 73 degree minus sec 73 degree and cot 67 degree. Ultimately 0. Now I have bonus question and the answer will be given in part 2, that higher order thinking skill questions. Question number 1, find the value of tan 1 degree, tan 2 degree, tan 3 degree, tan 88 degree, tan 89 degree. And next question is, in an equilateral triangle ABC, the length of each side is given 6 cm. Then find sine of angle A. So if you want to write the answer in the comment section, you are welcome. And I'm going to give the answer in the next video. Thank you for watching. That's all for this video.